Right, so now I want you to try first, right, before I actually provide you the solution for checking. So please try this one. Okay, I will discuss with you later after 2 minutes. Okay, we're supposed to use a quotient rule. So we are using this formula U V. Okay, so according to the formula, the differentiation will be, we take the V first, then we differentiate the U, minus, we take the U, we differentiate the V, over V squared. Okay, so now it will be good, all right, if we actually differentiate first, so we do not have to do everything when we solve this. Oh, we differentiate the U first. So differentiate the U, we have 2, get 2. And also we differentiate the V. Differentiate the V, we have 3. So this is U. And differentiate U, we have 2. This is V. Differentiate V, we have 3. All right, any questions here?
No.
Okay, thank you. Now we are going to start the differentiation. All right, we combine everything and using the formula. First we take V, so I'm going to take 3x minus 2. After that, take du dx, so it is 2. And minus, take u, so u is 2x plus 1. And take dv dx, still dv dx is 3. Divided by v squared. The v is 3x minus 2 squared. Okay, 3x minus 2, this is v, and then we have a square here. Okay, any questions here? As usual, we need to simplify first. And we have 6x minus 4. Okay, so this is another 6x, right? So minus 6x and minus 3. So from here we have 6x minus 6x, 0, negative 4, negative 3, negative 7, 3x minus 2 square. All right, any questions? Now the Solution does not end here because we need to find f double prime. We need to find the second differentiation and the value when the x is 2. Okay, so this is what we do, right? Now, as you can see here, now we can actually differentiate again using the quotient rule. But however, the -7, the numerator here does not have x. So we can actually use a much more easier way to solve. We use the chain rule. Okay, change this one. 2 to the power of -2. We bring this one up. And we use the chain rule to solve this. -2 bring down times -7. We have 14. Okay. Right. So we have 3x minus 2. We copy. -2 minus 1. So we have -3 because -2 minus 1. Differentiate inside 3. So we can actually find the second differentiation by using the chain rule. We differentiate the outside one. Okay, -2. Then we differentiate the inside one. We get 3 and we multiply. Therefore, the answer is 14 times 3. What do we get? 42, right? And 3x minus 2 to the power of -3. We can leave our answer like this. Okay. Do you have any questions, students?
So I don't need to sub the 2 inside.
Oh, yeah, huh? Correct. Sorry, we need to sub the 2 inside. All right, I forget this part. Okay, so sub the 2. So we have 42, 3, 2, minus 2, -3. So of course you can solve using the calculator. I will have 6 minus 2. 4. 4 to the power of 3. 64, right? So I have 42 over 64. We can simplify this one is 2132. Okay, please check my answer. All right, I calculate it manually.
Yes.
Yes, thank you. So this is how we find the second derivative. We differentiate 2 times using the 7 differentiation rules we have learned before. Okay, now let's move on to the next one. Okay, now we need to actually find this. In this section, we need to find the slope of a graph using the differentiation. Okay, now there is one concept called tangent. Now I want to explain this one first. Okay, so what is a tangent? I'm going to bring the graph here. Okay, now let's say we have y equals to x squared. Now you know this, okay, this is the function. This is the graph. Okay, now how do we find the slope, let's say, at this point? At the point 1, 1, how do we find the slope here? Okay, now before we learn differentiation, before we know differentiation, there is one way we can find the slope at this point. Okay, what do? We actually draw a straight line that touches this point. So when we draw a straight line, okay, now I'm going to draw a straight line. And then, okay, we draw the straight line to touch this point. You see, with this straight line touches this point. Okay, just one point only. Now, this is not, okay, this line is not considered the right line. Okay, this one also cannot. Okay, so we need to find one straight line that touches this point. So we draw it. Okay, now this line is called the tangent line. Okay, this line is called tangent. All right, now after we find the tangent line, this line, we are going to find the slope for this line. So what is the slope for this line? Okay, student, any idea? What is the slope for this line? Now you can see this is the equation, right? Y equals to 2x minus 1. This is the equation. So this equation represents the tangent line, all right, at this point. So what is the slope?
2.
2. Okay, good. Now, if you can tell me it is 2, right, means that you get the idea. So the slope is 2. The slope for this line is 2. Therefore, we can say, listen carefully, student, we can say the slope for the curve at this point is 2. But only for this point. Okay, student, the slope is only, the slope 2 is only valid for this point, for this curve. Okay, what I mean is, for this curve, y equals to x squared, at this point, the slope is 2, but not for others point. Okay, for example, now I take another point when the x is 2. Okay, I want to find the slope for this point again. So what do? I need to actually draw another tangent line that touches the point. Okay, so you can see here, this line is not the tangent for this point. Okay, it's not a tangent for the point 2, 2. It is not. Sorry, it's supposed to be 2, 4. So it's not the tangent line for this point. Therefore, this tangent line cannot find the slope for this point. I need to find another tangent line for this point. So I need to draw another line. Okay, minus 4, yes. Okay, so when I actually draw another tangent line here that touches this point, so this is the tangent to the curve at this point. I repeat that, this black color line is the tangent to the curve at this point, 2, 4. And from here, I know that when the slope is 4, then the slope of the curve, y equals to x squared, right? The slope for this curve at this point is 2. Okay, so before we learn differentiation, we use the tangent line to find the slope of the curve. All right, so now we are going to learn about the slope of the tangent. Okay, we are going to, in this section, we are going to use the differentiation to find the slope of the tangent. So it means that we are doing it the reverse way. Okay, now let's take the example to understand the concept. Find the slope of graph of fx equals to x to the power 4. All right, of x when the x is -1, when the x is 0, and when the x is 1. Okay, so we're going to start with the differentiation. So when we differentiate, we get 4x to the power of 3. Okay. Now, when the x is 1, when the x is -1, so what do we get here? We have 4 -1 to the power of 3. So we get -4, right? So it means that at this point, when the x is -1, this tangent line, for this tangent line, the slope is -4. Is that okay? Right, let us verify with the graph. Okay, cancel this one. Our graph now is x to the power of 4. And we want to find the slope when the x is -1. Okay, for this point, we want to find the slope of the tangent. According to the differentiation, we get the slope is -4. So we put a -4 here. All right, so we move this line to this. Okay, we move the line. We move this line to this point. Okay, this is the one. So y equals to -4x minus 3 is the tangent of the curve at the point x equals to -1. All right. So now what I want to show you is that we can actually use the differentiation to find the slope of the tangent at the given point. Okay, so the same idea goes for second questions and the third questions. So where we have f prime x equals to 4x to the power of 3. Yeah. So when the x is 0, so the x is 0, so the slope is 0. Okay, so at this point, the tangent line is a horizontal line. The slope is 0. And when the x is 1, substitute the 1 into the x, we get 4. So at this point, the slope is 4. Okay, the slope is -4, and at this point, the slope is 0. Okay, any question here, students? So I give you a conclusion for this line. Now, the tangent line is the straight line that touches the curve at a point, at a given point. Okay, so for example, at this point, this is the tangent to the curve at the point x equals to -1. And this tangent line, right, is the tangent to the curve at the point x equals to 1. Okay, so we have to name it like this because there are many tangent lines along the curve. Okay, if we want to find the slope, we can use the differentiation. After we differentiate, we substitute the value of x into the differentiate function, then we can find the slope. Okay, so remember in the beginning of this chapter, I told you that what is differentiation? The differentiation is actually the slope, right? So this differentiation helps us to find the slope of this type of curve. Okay. Now, next, we are going to find the equation of the tangent line. So before this, we have learn how to find the slope of tangent line. Okay, before this, we learned how to find the slope of tangent line. Now we need to learn how to find the equation. Okay, before we start, let's do some revision. Okay, when we have a tangent line, we know that this line is a straight line, right? Tangent line is a straight line. How do, for a straight line, what does the equation look like? Student, for a straight line. Okay, what is the form of the equation? Are you still with me?
Y equal to mx plus c.
Okay, thank you. Y equals to mx plus c. So tangent line is a straight line. So tangent line will have this form of equation. To find the equation of a tangent line, we need to find the m and also c. Okay. All right. So now start with the function fx equals to x squared. So first we differentiate. Differentiate, we get 2x. To find the slope at this point, when the x is -2, we substitute the point -2 into the x. So f prime x -2, we have 2 -2, we get -4. So this tells us that the slope is -4. So we have the slope. Is that okay? All right, so we start with the curve. We start with the curve, the function. We differentiate. We get this differentiate function. Substitute the x -2. Right, at this point, the slope is -4. So we have the slope. Now we need to find the c. Okay, student, do you still remember last time when we learned this? To find the c, beside the slope, what are the information we need?
A point.
Good. All right, we need a point. So to find the c beside m, we have m already, -4. We need another point, x and y. So how to find a point? According to the questions, we already have the x. The x is -2. So how to find the y? We substitute into here. So when the x is -2, to find the y, substitute -2 into the function. All right, x squared, -2 square. Then we find the y is 4. So we have one point here, -2, 4. We have this point. Okay, this point is here. So now we can actually find the c. The m is -4, so we substitute -4 here. To find the c, we substitute one point, -2 and 4. So we substitute -2 and 4. And solve this, we get y equals to -4x minus 4. So this is the equation of the tangent to the curve at the point x equals to -2. Okay, now student, you can see my sentence is very long. I repeat again. This is the equation of the tangent to the curve y equals to x squared at the point x equals to -2. Okay. Right. Okay, any questions here before we proceed to the normal line? Do you have any question? Okay, let's continue. Now, equation of a normal line. Now, what is a normal line? Okay, this green line is the normal line. Now, the normal line is the line that form a 90-degree. A line that form 90-degree to the tangent is called the normal. So this green line is called the normal line. Now, in the following discussion, we want to know how to find the equation to the normal line. Okay, so we are going to combine with what we have learned in chapter 1. Okay, let's start with some revision. Now remember we talk about perpendicular line. Perpendicular. We learned this in chapter 1. Okay, now a perpendicular lines means that the lines that form 90-degree here. 90-degree. Okay, so the tangent and the normal, they are perpendicular. Okay, so then take note, tangent and normal, they are perpendicular. So we can use a perpendicular formula to relate the tangent and the normal. Can you give me the formula? What is the formula for perpendicular lines?
M1 times M2 equals to -1.
Okay, very good. M1, oops, sorry. M1, M2 equals to -1. Okay, so we have this one. Okay, this is the formula that relates the tangent and the normal. So we can say, since tangent and normal, they are perpendicular, so we say the slope of tangent multiply the slope of normal, they are -1. Okay, so remember this. We are going to use this one to find the equation of normal line. Okay, I'm going to erase this. So, how to find the equation of normal line? Let's take a look on this example. Find an equation of normal line to the graph of fx equals to x squared when the x is -2. So this is exactly the same function, the same point, right? Compare with the previous example here. It's the same function, same point. Now from here, we already know the slope of the tangent from the previous example. And the slope of the tangent is -4. Okay, so to find the slope of normal, okay, the slope of normal, so we are going to use this formula here. So the slope of normal will be -1 over the slope of tangent, and which is -1 over -4, so we get 1/4. So this is the slope of normal. All right, so we have here. Now again, since the normal line is a straight line. The normal line is a straight line. We know that the equation must be in this form, y equals to mx plus c. All right, this line, the equation will be y equals to mx plus c. We already found the m. To find the c, we need 1 point. Okay, do you think we have the point? Okay, student, do you think we have a point? Yes, we do. We have a point. What point? The same point here. 2, -2, 4. Right, it's the same point, -2 and 4. So use this point, -2 and 4. Right, we get this point, the previous example. Substitute into the formula, -2, 4. All right, and solve it. We get 1 over 4x plus 4.5. So this is the equation of the normal. Okay, any questions here? Okay, now if we do not have any questions, all right, let's solve this exercise. Okay, so you can proceed to solve. All right, I'm going to show the solution here. Find the equation of the tangent to the curve fx equals to x squared plus 1 at the point x equals to 1. So we want to find the equation of the tangent at this point. Now, just for your illustration, so let's say x squared plus 1, all right, we know it's a quadratic. So the graph will be like this. Right. So when the x is 1, okay, now for example, the point is here. Okay, x is 1. So we can actually draw a tangent line. Okay, so this line is the tangent. We want to find the equation of this line, tangent. All right, so this curve is y equals to x squared plus 1. So how do we find this point? First, we need to find the y. The y is f when the x is 1. So we have 1 squared plus 1. The y is 2. Okay, therefore the point is 1, 2. Okay, find the slope. To find the slope, we differentiate the function. So we have 2x. So when the x is 1, okay, when the x is 1, so the slope will be 2 times 1, which is 2. All right, then we know the slope is 2. Okay, to find the c, the equation of tangent is in the form of y equals to mx plus c. And now we have y equals to 2x plus c. So when the x is 1 and the y is 2, so we substitute the y as 2, the x is 1, and we can find the c is 0. Okay, and then we have the equation of tangent. Sorry. Okay, the equation of tangent will be y equals to 2x only. Any questions? Any questions, students? Now, let me show you the graph for illustration for you to understand it. So y equals to 2x. Okay, now this graph is y equals to x squared plus 1. All right, the curve, right, the red color one is x squared plus 1 equals to y. And right, to find the tangent at this point, right, when the x is 1, all right, so from the differentiation and from the point, we actually get this tangent line. Okay, the tangent line, the equation is y equals to 2x. Okay. Now, if you do not have any questions, let's proceed to the last one. Okay, the last example of today. Okay, we need to find the equation of tangent of fx equals to x to the power of 3 minus 12x plus 2 at the y-intercept. Okay, now suppose when we look at the function here, we do not know the graph. So this graph is for explanation only, right? Because when we look at the graph here, right, we are not sure what does the graph look like. Okay, so right, let's say we have a graph, right, at y-intercept, right, when the x equals to 0. What is the x here? X equals to 0, right? Okay, y-intercept is here. Okay, when the x is 0, we want to find the equation of the tangent at this point. Okay, so we are going to start with x equals to 0. And what do? We find the y. Okay, so substitute 0 into the function. We get the y is 2. Now we have a point. Okay, we have a point, 0 and 2. So we need this point to find the c. Okay, now after that, what do? We find that to find the m, we need to differentiate. Okay, so step 1, you find the point. Step 2, find the slope. How to find the slope? Differentiate. So differentiate this, we have 3x squared minus 12. And now substitute the x equals to 0 to find the slope at this point. So 0, substitute inside. Okay, so we get negative 12. And we know now the slope is negative 12. Okay, now finally, when the slope is negative 12, and we have 1 point, we know that the tangent is a straight line. It will be in this form, y equals to mx plus c. So we substitute the slope, negative 12, and 1 point, then we are able to find the c, and the c is 2. Therefore, all right, this is the equation of tangent, which is y equals to negative 12x plus 2. Okay, is that any questions here? Is there any questions? All right, now students, for differentiation, okay, in the final exam, you have a very big portion on this thing. Okay, so it will be about, out of 100%, you will have about 35% on this. All right, another 35% will be on the integration. Okay, so you need to actually master this topic in a good way. All right. So now then, all right, our first part of differentiation come to the end. So you need to know the 7 rules of differentiation. And after that, you need to know how to find a higher differentiation. And after that, you need to know how to find the equation of tangent and the equation of normal. Okay, so right, any question before we end our section today? Now, if you do not have anything to ask, all right, then we are going to end our section now. So please take note that we do not have class participation activity today. Okay, so thank you very much. And I will see you during the tutorial time.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you,
Thank you, sir.
Thank
Thank
you.
you,
Thank
sir.
you very much. Thank you.
Thank you, sir.
Thank you. Keming, very loud, Keming.